So in this particular example, we're running both confederations and root reflector. Now, as we know, both confederations and root reflector as devices are simply designed to reduce the number of internal BGP neighbors because, of course, there's a requirement to fully mesh it. So they're really not doing anything else. They can introduce a little bit of complexity, but that's their overall goal. As transit routes cross the internal BGP cloud, those neighbors are meant to be fully meshed in order to deliver the routes correctly without having routing loops and holes, and hence the full mesh requirement, hence confederations and route reflectors. So we're running both here. You can see that we have two mini ASs in a confederation, 65001, 65002. Of course, the real AS number is 23.89. And then inside the left mini confederation sub AS, we have a route reflector. And again, that's simply designed so that these four routers here don't need to fully mesh. They can each just peer with the route reflector. So how do we configure it? Well, it's a little bit unusual. When you configure confederations, you actually tell the router that its autonomous system number is the mini confederation number, which does take some getting used to. And then the real AS number, which in this case is 2389, you tell the router that that's the confederation number. So it is a bit odd, but of course the router will know the members that are in the confederation, the sub ASs, and it knows from this that it's one of those sub ASs. And what that means is that as it connects from confederation sub AS to confederation sub AS, it will represent itself as the sub AS. However, it knows that the true confederation, which is the true AS, and its number. Okay, so the key to unlocking this is that every single router is in the confederation. So it doesn't matter if it's R7, the route reflector, R3, R5, they're all within the confederation. They're all going to need an almost exact piece of code here to say they're in the confederation. Obviously, the routers on the left-hand side in 65001 need to represent themselves as 65001. The ones on the right-hand side need to represent themselves as 65002. But other than that, this section here and this section here are the same and need to be in every router. Okay, so the next thing that we have to do is to turn on some internal BGP, which is really what this is all about. So, in this sub AS here, we have a route reflector. Consequently, we need to pair with the route reflector, but we don't need to pair with all of the other BGP speaking routers. And of course, we don't need to be directly connected to the route reflector. Do bear in mind that for this, we have turned on ISIS on these two lines from the router 3 to the route reflector and router 4 to the route reflector. And remember that the route reflector is going to be reflecting the routes, but isn't going to be playing a major part in the data path. So therefore, we do have to have ISIS on so that the routers can find each other's loopbacks. Okay, but for this particular screen, we're just pairing up to the route reflector. So you can see here that we've got a BGP group internal, we've got the local address set, we've got a neighbor here, which of course is the route reflector, and we're setting it passive. And what we're really saying there is we have an extra requirement that the route reflector is going to initiate that BGP port 179 TCP connection. Okay, now down here, of course, we have the route reflector. As expected, it is going to need the same confederation information as we previously said. And of course, as a route reflector, it's going to need a cluster. So here we have a cluster ID. You must have one. Even though there's only one, you have to name it. So there it is. And of course, the route reflector needs to pair with all of the routers in this particular side. Okay, so what next? Well, we have to have communication between the two sub ASs in the confederation. So we need a BGP group. We've called it sub AS 65002 because of course this is on router 3 and it's going to be speaking to 65002. And on router 5, we would have an identical section, but of course this time representing itself as 65002, and there'd be a group there called 65001, which would be its router 3 and router 4 neighbour. So we can see, as with any BGP group, we've got ourselves our local address, we've got ourselves our neighbour, and we're setting multi-hop. And this is particularly important with configurations. It's very likely you'll need this. And if you actually have a look, router 3 isn't directly connected to router 6, so it really is a true multi-hop. Okay, so that sets the confederation up, sets the two different sides. What's happening in the second mini sub AS, 65002? Well, it configures exactly the same way as 65001. Here there's no route reflector, so we will need to fully mesh. So router 1 will need to fully mesh with 5 and 2 and 6, and 5 will need to mesh with 2 and 6 and 1. And I've drawn that here as a small cloud and written full mesh with IBGP. Of course, we have the standard group internal, we have the local addresses, we have the neighbours, and as we've said, we have all of the configuration for the confederation. And on router 5 and router 6, it's going to be running this confederation BGP in the same way to match the statements on router 3 and router 4. Down on router 8 and router 1, of course, we're running external BGP, a normal flavour of external BGP, and that's running down to these external peers. And then the final note is that router 7 and router 8, here they again will need all of the confederation information, and they just have the single pairing to the route reflector.